Good morning and welcome back to the shed. I'm afraid I have a problem. It appears there's something wrong with my 2000 watt pure sine wave power inverter. So if I turn it on, all turns on, we get an output, but if I plug in a heavy load, this is what happens. The output, can you show? So let's trip the output, there you go, power trips. So the power output of the inverter turned on and off. Yeah, I can't even get the voltage up. And it's making the, I don't know if you can see it on camera, it's making the light flicker, making the light flash, so it's clearly pulling the battery voltage down because that is fed straight from the batteries. So I'll turn it off before it causes any more bad things, and I'll take it off the wall. So with the main inverter out of action, I'm going to need to have power in order to repair it. So I've got here a 300 watt modified sine wave inverter, which is nowhere near as powerful, but will be a temporary fix. Now this is 12 volt. Bing! I've got a 24 volt battery, so I'm going to need one of these. This is a 12 to 24 volt step down converter. Step up converter even. No, step down converter, I'm talking rubbish, aren't I? And because this takes a surge current this can't handle, I've got a bank of capacitors on the output, on the input, so it's all a bit of a faff. But I'm going to screw this to the wall temporarily once I take my other inverter off. I'm not looking forward to this job because it's going to be horrible. And I may have to make it up some wires and ring terminals to fit it all. Oh well, let's get down to it. Well, it's off, and I know what you're thinking. I've done such a good job at that. It doesn't actually look temporary, does it? So what I've done, the high current leads for the old inverter, I've just screwed them to the wall there and there to keep them out of the way, so I don't want them flailing around. Got the DC-DC converter there. New temporary inverter, excuse the wires poking out of it. Capacitors hanging on a bunch of batteries, perfectly safe. And 300 watts of pure power we have in the shed. So now, I've got to take the old inverter apart and see what's wrong. So this is I suppose it's a clamshell design. You've got two screws at the top that you take out and the whole thing lifts up. And I can't do it one-handed. So I'm going to have to pause it, open it, and then have a look inside. If that makes sense. And this is all the invertery goodness. Now, I was kind of hoping, like last time I opened one of this up, there was a capacitor that had exploded. I was hoping to see something similar. Although that capacitor there looks a bit wonky, doesn't it? I wonder if that's gone a bit funny at the bottom. But on the surface of it, it looks okay. Do they look a bit bulgy? Potentially. It's disappointing, isn't it? Oh, there's a wire hanging there. What's that wire from? Ah, it's from the fan. That'll be why the fan doesn't work. That resistor down there doesn't look particularly healthy. Looks like it's got very hot at some point. There should be another one down here. Oh, that looks a bit mean as well, doesn't it? So the socket top of that's cracked or something. I don't know what they're doing. Like all these. That's what this one's doing. I'll focus. Yeah, not looking happy, are they? Is that just an age thing, or is that actually where it's overheated? What's this one down here look like? Can I get in there? Come on, push that wire out of the way. Now that one doesn't look very happy at all, does it? Is that our problem? Well, probably doesn't help, does it? Alright, I think I'm going to take these boards out of this housing, and they slide out. They're on these rails, so you can just take the ends off, slide that out. You've got to take this back end off, and then slide that out. So I'm in super zoomed in mode, so if you can't see what's going on, let's super zoom out. Woo! There you go, that's fun. Yeah, so slide that card out, take the rear connector off, slide that card out. Bit of wildlife in here at the moment, which is lovely. Unbolt these, unbolt that, do that, just take it apart. Yeah, why not? Before I remove the card, you've got to take off all of these fixings, and some of them I didn't drop in, unlike that one, which I did drop in. So I've got to get that out. But yeah, once that's all done, you can then bend these capacitors, transistors and FETs away from the heatsinks. I've already had a bean in here once before. Seen other videos on my channel, I've already taken this apart for other things. Not the most reliable. That doesn't look good either, does it? That looks like that's leaked. Oh, could be a lot of stuff wrong with this. Burnout resistors, leaky caps. These are quite expensive, about £200, £400 for a new one. It's coming to the point of go, can we bother to fix it? I think I should try at least, shouldn't I? Yeah, as I said, spider. That board's out anyway. And I'm afraid to say, it bit me. Bastard. Well, yeah, I'm going to sort out my wounds and then we'll give this another go. Oh, crap, it's actually ringing quite badly. All good fun, eh? Plaster fitted. Wound sealed. So my finger's fixed. This isn't though. So that resistor is measuring at 5.7 ohms. So call it a 6 ohm resistor. Both sides. We're sure the ones down the bottom there are exactly the same because they should be the same circuitry. So we need 4 of them. We've got a leaky cap here. So chances are we're going to have to replace all the caps. So all these caps here are the same. So they're 450 volt, 68 microfarads. So these the same as well. Where's the number on them? No, they're different. They are. Can you see it upside down? What are they? 40 volt, 4.7 millifarads. Okay. So we've got 2 of them. 2 of them. And we might as well change these, whatever these are. These are 250 volt, 220 microfarads, is that? I think that's a microfarad, that must be. So yeah, so I'm going to look at the price of getting all these caps. And also I'm going to have to get new seal pads because I managed to break these. And you want these to be insulated from the chassis, otherwise it will blow up again. So I'll price that up. I'll also have a look at new inverters because can't be bothered to fix it because I've got to take it all apart, get it all out, and it's horrible. And if you look at this, soldering on this just looks a bit crappy anyway, doesn't it? Look at that. I mean, that is flux still, but it doesn't look great, does it? So, and there's a dead spider. Don't really want to be dealing with that. So it's a case of can we bother to fix it? How much is a new one? I'll go away. I'll have a think, and we'll see. I mean, this has been around a long time. One of my earliest videos was making this, disabling the soft start on this controller board. I think it was about 2012 I did that. So yeah, so it's probably over 10 years old, this inverter. I'll have a look. I'll have a look around, making my mind up. But this will be updated shortly, I'm sure. In the future, you'll see a video about what I decide to do with this inverter. But for now, have fun. I'm going to go get a cup of tea, and I suggest you probably do the same. So, see you later. Bye for now.